Section 3 is all about angles and special segments in a circle. So we're going to start off going over a couple of new theorems. The perpendicular bisector theorem says a diameter or radius of a circle is perpendicular to a chord if and only if it bisects the chord and its arc. So what does that mean? It's saying that if this radius from O to C is perpendicular to this chord AB, and that kind of shows right here, they're perpendicular. That means AP is equal to BP, and they kind of show that with these extra tick marks here. What else is that telling us? Well, it tells us that the measure of this arc A to C, remember this is measured in degrees, that equals the same as this one, BC, and that each one of those, so those are the exact same, AC is the same as CB, and if we were to add those up, they would add up to this one, A to B, and each one of those is exactly half of AB. Now, again, only one of these things needs to be true to imply everything else, because it's the if and only if statement. If all we knew was this is perpendicular, then we know for sure this is true, and that this is the same as this, and they both add up to this. Same thing, if we didn't know that this was perpendicular, if they only told us here's a radius, here's a chord, and these are the same as each other, well then we'll know these two are the same as each other, they're each half of this, and that this is perpendicular. So because it's the if and only if statement, you only need to know one of those things and the rest would be implied. Congruent chords theorem. In the same circle or in congruent circles, two chords are congruent, again, if and only if they are equidistant from the center. So if we were told that CD is the same length as AB, oops, that one got off. If we were told that those are the same lengths, we know for sure they're the same distance from the center. In the same way, if we got rid of all that and we said, okay, this distance from here to here is the same as the distance here to here. Now these would always be to the exact center, they'd be drawn perpendicularly. If we know that this is the same as this, then we know for sure that C to D is the same length as B to A. Has to be true if and only if, so it goes both ways. Last little theorem here, the parallel chords theorem. In the same circle, parallel chords intercept congruent arcs. So if this line is parallel to this line, that AB is parallel to CD, then this arc, AC, is the same as this arc, BD. Same thing, other way around. If we weren't told that that was parallel, if we were told this arc, AC, measures the exact same as this arc, BD, then we know for sure, hey, AB has to be parallel to CD. And again, it's kind of the if and only if. It goes both ways. One implies the other. So let's look at some examples. Using that perpendicular bisector theorem, given circle Q, so we always name it by its center, and we know that WX is 10, and that the measure of WPR, so I'm going to draw that on here, WPR, this larger arc right here, we know that that large arc is 150, and if it helps, remember that that is degrees. We measure that arc measure in degrees. We measure the arc length in centimeters or feet or whatever it is, but this, because it has the M in front of it, it's asking for the measure in degrees. We want the measure, so in degrees, of just WP. That's our first question, is how big would this one be? Remember, this is always going to be half of it, so half of 150 means that this one would be 75. And again, if it helps, remember that that is degrees. This is 75 degrees in total for this arc. Let's look at the length of W to R. I'm going to use a line on this one, blue and green, from here all the way to here. So if just this length is 10, We want to know the whole length. Well, if this is perpendicular right here, it means both of these are the same. This one has to be 10 as well. So the whole thing together would be 20. So you just add those two pieces up and the whole thing becomes 20. Again, if it helps, write down maybe that it's inches or it's feet or if it's miles, whatever it is. This is 10 inches, this is 10 inches. So the whole thing is 20 inches. This one is a length or distance, so it has to have some sort of distance measure. This is an arc measure, so it's in degrees. Don't confuse these with being like 75 feet or 75 miles. This is a degrees, this is a length, so a distance. If qx equals 5, so this length here is 5. And again, if it helps, we'll write in 5 inches. So this is 5 inches, this is 10 inches, and we want to know what's the length from Q to P. So that's going to be here to here. Notice that is a radius. So we're trying to find the length of the radius. Now, just because this is 5 doesn't mean that this side is 5 as well. These two pieces are not necessarily the exact same. Only these ones are, the 10 inches here and the 10 inches here. But this radius from Q to P is the same as all of the radiuses or the radii around the circle. So if I were to move it, say, to here, now this radius with this 5 inches and this 10 inches makes a right triangle. So I'll call this one R over here for radius. We have R, 5, and 10. So I can use my Pythagorean theorem to find how big R is. I just plug everything into the Pythagorean theorem. 5 squared plus 10 squared equals R squared. Right? A squared plus B squared equals C squared. 5 squared is 25, 10 squared is 100. So we have 25 plus 100 equals R squared. We combine those together and we get 125 equals R squared. Take the square root of both sides. So we have the square root of 125 equals R. So that's approximately 11.18. So that would be just one radius is 11.18, which means even over here, when I move it to QP, that's still 11.18. So this would be my radius measure, or my QP. Here we have a proof. We are given circle Q, so this circle given by its center is Q, and we're told that SR equals TU. So I'm going to draw that on here, red. This length is the exact same as this length. Put that in little marks. This is the same as this. And we're trying to prove that this arc, so this blue arc, is the same as this blue arc. So essentially we're trying to prove the congruent chords theorem that we learned in our last unit, or last lesson. We're trying to prove that that is always true. So for our proof, we'll say we'll start with circle Q, and we know that SR equals TU, because that was all of our given stuff. So reason number one is always just that it's the given. Now if we look at this, let me use blue for this one. Q to R is a radius. So is Q to S, that's a radius. So is Q to T, that's a radius, and Q to U is a radius. So all of them are the same radius, which means they are all equal to each other. QR equals QS equals QT equals QU by the definition of a radius. They all have to be the same exact length. So I'm going to do 2 tick marks on that, that, and that. Now when we look at it, we've got 2 different triangles here. And we know from our congruency theorems before, we can say that triangle RSQ is congruent to triangle TUQ. What lets us say that they're the exact same? Side, side, side. This side is the same as this one. This side is the same as this one. This side is the same as this one. They're all the same. We have 3 matching sides. So those 2 triangles have to be the exact same. If they're the exact same triangles, I can say that this angle is the same as this angle. So I would say angle Q or RQS equals TQU. Why can I say those angles are the exact same? Corresponding parts of congruent triangles are congruent. These two pieces match up, so these have to be the exact same angle. Now, if this angle is the same as this angle, then the arc that it makes has to be the same as the arc that this one makes. So we would be able to say the measure of arc SR equals the measure of arc TU. Why is that true? Because of the definition of arc measure. Because these angles are the same, their arc measures have to be the same. So again, remember, in the end, that's just proof that that arc-chord congruency theorem works. And that was the last part that we looked at in our last lesson. Last example here, we are given that MQ, this arc, measures the exact same as NP, this arc. So we need to find x. Well, if these two are the exact same, we can just write an equation saying they're the exact same. 83 equals 2x minus 27. So to find x, we would just add 27 to both sides. So we'd get 110 equals 2x. Divide both sides by 2 to get x alone, so we would get 55 equals x. And that's how we would solve for x in that case. We'll call it quits there for our first video.